Today I'm going to make the chemical copper chromite, which is an inorganic compound that can be used as a pretty versatile catalyst in a variety of chemical reactions. In certain circumstances, copper chromite can be used in place of Raney nickel, and I plan to use this batch to make pyridine from niacin. Pyridine itself is an incredibly useful chemical that can be further used to make a huge variety of compounds, including several cool organometallic complexes. Anyway, to make copper chromite, I first needed to make copper ammonium chromate, which will decompose to copper chromite when heated. Technically, pure copper chromate or any copper chromate double salt will also decompose to copper chromite, but the ammonium version decomposes at a much lower temperature than its alkali metal counterparts. To make copper ammonium chromate, I began by dissolving 25 grams of copper sulfate pentahydrate in around 200 milliliters of water. In a separate beaker, I then dissolved 29.4 grams of potassium dichromate in around 75 milliliters of water. This represents equimolar quantities of copper sulfate and potassium dichromate, and about 1/10 of a mole of each one. Without really waiting for it all to dissolve, the potassium dichromate was next basified using a large excess of 30% ammonia, which will cause the solution to turn from orange to yellow. This distinct yellow color is due to the conversion of potassium dichromate to potassium and ammonium chromate, and the large excess of ammonia will guarantee that copper ammonium chromate rather than copper potassium chromate is the principal product. At this point, the yellow mixture of alkaline ammonium and potassium chromate is slowly added to the mixture of copper sulfate, which will immediately begin to precipitate the insoluble copper ammonium chromate, which is somewhere between a brick red and deep brown color. I suspect my yield might have been better if I added the chromate under constant stirring, but I always like to try out new displacement reactions without stirring to see how they look. Now, in my opinion, even if the yield did suffer, I think it was worth it, as this reaction was absolutely gorgeous in its unique display of color. The contrast between the bright yellows, blues, greens, and browns was pretty awesome to see in person and much more visually interesting than anything I thought might come out of this project. Regardless, I did eventually turn on stirring after I had added the remainder of my ammonium chromate. The larger addition revealed clearly that the reaction is somewhat exothermic, which could be a concern at a much larger scale. This was allowed to continue reacting for 5 minutes under constant stirring, which left me with a brown slurry that looked very much like clay or mud. This was then passed through a coffee filter to collect my copper ammonium chromate, which also filtered very much like mud. I did at one point try vacuum filtration for this step, but given the extremely fine particle size, doing it this way is a complete nightmare, and I don't recommend it. Anyway, I let this continue filtering for as long as filtrate was still coming through. The filtrate here passed through as a deep lime green, and at the time I really wasn't sure what chemicals were responsible for the distinct color. However, after a bit more testing, I found that it's mostly composed of blue tetraamine copper sulfate, along with smaller quantities of green chromium 3 sulfate and a bit of yellow chromate. The existence of chromium 3 here was a bit surprising, as it shows that the reaction did reduce some hexavalent chromium to trivalent chromium. This would definitely explain the exothermic nature of the reaction, but I really have no idea what the reducing agent could have been here, and if you do have any ideas, feel free to leave them in the comments. Anyway, once I drained as much liquid as possible from my copper ammonium chromate, I next transferred it to a large watch glass to dry. There is definitely still a lot of salt contamination in here, but given how difficult it was to filter this crap, I decided to remove it later. After a couple of days had passed, the copper ammonium chromate was now completely dry, and had turned from a dark chocolate color to something of a rusty orange. This was next powdered in a mortar and pestle, and it's important during this step not to inhale any of the dust, as this is still hexavalent chromium. Once it was completely powdered though, I transferred it to a porcelain crucible which was suspended above a Bunsen burner. I lit the Bunsen burner and slowly heated the copper ammonium chromate to decompose it to copper chromite, which happens above 400 degrees Celsius. This results in the powder slowly darkening until it's a uniform black color, which for me took about 15 minutes. At this point I cut the heat and allowed the crucible to cool. Once it had cooled down to room temperature, the powder was carefully scraped into a beaker along with 10% acetic acid, and this was stirred for about 15 minutes. This step was important to remove all of the chromium oxides that had formed as a byproduct of the decomposition, as well as any copper oxides that might have accidentally formed. Chromium oxide and copper oxide will readily react with acetic acid, forming copper acetate and chromium acetate, which are both soluble and very easy to wash away. After this had spent a little over 15 minutes reacting, the resulting mixture was passed through vacuum filtration, and this time the filtering took only about a minute as the copper chromite didn't stop up the filter the same way the copper ammonium chromate did. The resulting copper chromite was transferred back to the beaker and rinsed again, this time in distilled water, for about 5 minutes. This was filtered off a second time and then rinsed until the filtrate ran clear, at which point the now clean and salt-free copper chromite was transferred to a dish and dried overnight under vacuum desiccation, which was honestly a bit overkill. Once I was certain the copper chromite was completely dry, I went ahead and weighed it for a final mass of about 20 grams, representing a 64% yield. This seems pretty good to me given how much unreacted copper and chromium I recovered from the first filtration, and honestly I didn't even need this much to begin with. Visually speaking, copper chromite is a sort of greenish-gray powder that looks black except in very strong lighting. This is only my first batch though, and I assume this could vary somewhat. Due to this unique color, copper chromite has found some limited use as a pigment, but as I mentioned earlier in the video, I plan to use this as a catalyst to convert niacin to pyridine, so keep a lookout for that video in the future. Anyway, I hope you found this interesting or useful, and as always, I want to thank all my incredible patrons for their generous contributions. Your support is vital in helping me continue doing what I do here, and very appreciated. As for announcements, just a quick reminder, I'm moving a couple of my energetics videos and posting most of the future ones to Patreon. I've opened up a $1 tier which will allow you to view these videos if you're interested, and if I can ever get a clear answer from YouTube, I'll try to post them here as well. Aside from that, I obviously have my pyridine synthesis coming up, followed by some organometallic complexes you can make with pyridine. I also have a video coming up on reliable ways to make nitrite salts, as well as different types of metal plating. I'm just currently trying to figure out gold plating without cyanide, because I really don't want to do that. If any of that sounds interesting to you, consider subscribing on YouTube, TikTok, Instagram, or even by becoming a patron yourself. Thank you all so much for watching, and I'll see you next time.